Oh, all right. So first of all, this is a true story. I did extensive research to try to find the tallest Ferris wheel in the world, and by extensive research, I mean I went to the Alkeck Library at Southwest Texas State University, and I went to the stacks, and I researched through volumes and volumes of encyclopedias, and that didn't work. So I came home and Googled it, and it said that it was recently built, the Ain Dubai. Ain Dubai. Um, it's much larger than like the London Eye and all those other famous ones. So it's located in the Blue Waters Island near the Dubai Marina in Dubai in the United Arab Emirates. Has anyone ever been there? It's plush, I imagine. It reaches a maximum height of 820 feet above ground. So that's way up here, 820 feet above ground. And it takes 38 minutes to make a full rotation. So these large Ferris wheels, they're not like the one at the Comal County Fair where, you know, you go round and round many times, right, on one ride. These rotate super slowly, and they just rotate continuously. So when people pay like $50 or $60 or whatever it is to ride the ride, they're in the carol, and then as the cart comes by, they're moving so slowly that people could just walk on without the ride stopping. So they move pretty slowly. And I guess the idea is not to go like wee, right, and have the wind blow through your hair. It's to like get up there and be like, wow, I hope this doesn't break, right? And you can see everything from way up there. All right. So it takes 38 minutes to go around. So assuming you, notice how I put you into it, did anyone think like, oh, I get to go for a ride? Oh, good. Yeah, put yourself in the front. So you walk on and boom, you start your stopwatch at t equals 0. So at t equals 0, you're at the bottom. Sketch the graph of your height, h, in feet, or units or feet, as a function of time t in minutes since you started your stopwatch. Be sure to label all your high axis low and critical values. Show at least one full cycle, so 5 critical values, and at least 1 negative critical value. Even though we started it at 0, the ride was still going before we got there. So having a negative critical value, you know, you could extrapolate backwards. All right, so the first thing that I did is I made myself an X and Y axis, right? And it's going to be mainly in the first quadrant. Let's talk about the vertical axis, the Y axis. It tells you it reaches a high point of 820. So you can just come here arbitrarily and put a mark at 820. I also told you that the radius of the wheel was 405 feet. And this kind of posed a problem for some people because it's really just simple subtraction. If you did the Ferris wheel problem in the notes, if you did the Ferris wheel problem in the worksheet, you know that the radius of the Ferris wheel ends up being the amplitude of the equation, all right? So if you want to think about the actual, a lot of people kind of labeled this. They said that this was, what was it? I forgot, 820, yeah? And then here is the center, right? So this is what I told you was 405. And that means that this is also 405, right? So the center line of the sinusoid runs right through the center of the Ferris wheel because it's going to go up 405 from the center, down 405, up 405, down 405. So where is the center line of the wheel? Where is the sinusoidal axis? It's at y equals 820 minus 405, which puts it where? 415. Yeah. A lot of people put that as 405. 405 feet above the ground. Imagine if you were 405 feet above the ground and the radius was 405. As you came down to the bottom, what would happen? You'd scrape the ground. You have to lift your feet. That's not a very fun ride. The insurance rates for them would be higher. No, that's not how that works. All right. It's 415. And now if you subtract 415 or 405 from 415, it puts you where? At 10. Okay. So you can think of this as the ground. So the ride, the place you get onto the ride is 10 feet above the ground, right? 10 feet above the ground. You don't have to lift your feet. You got 10 feet of clearance there. So those are the numbers that we need to transfer now to the y-axis. 10, 415, and 820. All right. So when you do that, again, I'm not concerned with this scale here being 10 and then that scale there being 405, because we could put like a break in the graph. That's not the most important scale that we want to preserve. The x-axis is. So what do we do with the x-axis? Well, I know that at 0, I'm at a low point. So if you want to go ahead and put a dot at 0, 10, you can. Because I tell you, when you get on at the bottom, you start your stopwatch at 0. Now all you got to do, since you know 0 is a critical value, it's unlike the Bay of Fundy where we observed it kind of at an off time, not at midnight. I said that it takes 38 minutes to go around one time. 38 minutes then is going to put you back at the bottom, yes? So if you come out to 38, right, you put that mark there. Oops, I'm in the eraser mode. Put a mark at 38. You bisect it, right, like we did. What's half of 38? 19, and then you bisect it again and you get 9.5. 9.5 then is your quarter cycle counting interval. So now you can continue to put more marks if you wanted. Just make sure that they're the same distance away from each other. And then you just label it. Count by 9.5s. 19, 28, 5, 38, 47, 5, 57. Some people put more, some people put less. And it said, oh, put at least one negative critical value. So 0 is a critical value. The first negative one would be negative 9.5, so on and so forth. Now, I highlighted the yellow piece because that is the least amount of graph that you needed, because that's one cycle. That doesn't map out our ride, but this goes from an axis going down to an axis going down. So that would be the bare minimum. That's one full cycle. It's not our ride, but it's one full cycle of the wheel, and it has at least one negative value. Our ride, right? We went around one time. Our ride is this. The red piece is our ride. And a lot of people went past 28.5, right? Because they wanted to get off the ride. So they went back to at least 38, right? If you forget to get off at 38, you're at $60 again, right? Or whatever it costs to go around. We should look that up at the end. I didn't look that up. I couldn't even afford to look that up. Google was asking me to deposit more quarters and I didn't have any. That's a payphone joke. You know what that is? Used to call long distance on a payphone and the operator would interrupt. Excuse me, you need to deposit 10 more cents or 25 more cents to continue the phone call. And you're like, who are you? I'm talking to my dad. How'd you get in here? Right? Okay, I guess I'll put in another quarter, right? Yeah, back in the day. All right. And now all we got to do is continue putting our dots on there, right? Putting our dots. Since we know there's a low point, it's pretty established that the only place to go is up, right? When you're down, the only place to go is up, right? So axis high, axis low, axis high, and then you continue. Now, I connected these dots with notability. Notability allows you to, establish an arc with 3 points, and then you can shape it how you want, right? Like that. But on the test, you couldn't do that. So I was looking to see if you went from frown to smile, smile to frown. Okay. If you were too haphazardly drawing it, like some people, believe it or not, some people sketch the sinusoid without putting the dots there first. That would be like eating the food without putting it on your plate, right? You're just a savage, right? Just like an animal, right? Those people did not get the check for the graph, okay? So we set the table and then we put the food on it. So this was worth 3 checks, and tomorrow it'll be also worth 3 checks. You get 1 for basically your x-axis information, 1 for your y-axis information. So if you had 405 here instead of 415 for the sinusoidal axis, the center line, you didn't get the second check. And then 1 for the graph. I was looking for really 2 things. Did you start low at 0? That was important. Did you start low? And then frown, smile, frown, smile, frown, smile, or smile, frown, smile, frown. Okay, so that was worth 3 checks. I did ask you to label your axes. Some people did, some people didn't. I decided not to deduct for the people that didn't, but because I'm telling you now, tomorrow, we need to improve upon that, right? We need to get better. So you need to add T, not X, and then units in minutes for the x-axis, and then H of T and feet on the y-axis. You don't have to label it like the height of me above ground, or my height, not to use the passive voice, my height above ground on the awesome Ferris wheel. You don't have to do that, but label your axes. All right, now tomorrow on the redo, it'll be similar. I'm just going to change the numbers. Okay, you're going to be riding a Ferris wheel again. At t equals 0, am I going to put you on the bottom? Or am I going to make you try and get on the Ferris wheel at the top? Yeah. I can make you get on at the bottom, but then you don't start your watch until you're at the top. So be mindful of that. I may get crazy like that, but more than likely, I'm going to make you get on at the bottom and start your stopwatch again. But it's going to be a different Ferris wheel. We may be in a different land. All right. Yes. Yes, in class. But everyone's getting the opportunity to redo the free response, and then I'm going to average your two for your first original grade. So it's not a retest. This is a half credit back on what we did yesterday. All right. So if you got 0 out of 10 yesterday, and you make all 10 tomorrow, you get 5 out of 10. Right? Nice, baby. And I'll round up. So if you got 5 out of 10 the first time, you can get back to 7.5 out of 10, which, I'll round that up to 8 because I'm nice. Yes, I am nice. Thank you. All right, high five. Another question, little wine? So say we got like one number wrong on the y-axis. Yeah, then you didn't get. Well, kind of. Yeah, I'll talk about that. Yeah. What do I do if you had one wrong number? Well, there are ways to recover points, but there are also exclusions that keep you from recovering. Okay, you have to be playing a very, very similar ball game if you're not playing the same game, right? Like if we're all playing baseball and you show up like with football pads on, like you're playing the wrong game, right? But if you show up like wearing baseball, but you're like, I don't know, you're playing paper, rock, scissors in the dugout, I'd be like, well, at least you're here and you're ready to go, right? Come on, let's go. Right, you play kickball. There you go. I was trying the softball, right? Softball. Yeah, play softball or kickball. Man, remember the kickball at reset? Oh, right. Thunderfoot. All right, so that's A. Any questions on A? All right. Assuming that H is sinusoidal function of time, write an equation. All right, so let's go ahead and go for it. Since I started you at the bottom of t equals 0, most people wrote a negative cosine, right? Negative cosine starts at the bottom. You wouldn't need a phase shift. But if you wanted to shift to the right and put minus t minus 9.5, that would be a positive sign. If you wanted to do t minus 19, that's positive cosine. If you wanted to do t minus 28.5, that's negative sine. If you wanted to do t plus 9.5, that's also negative sine. You have options, right? But the easiest one is the no phase shift one. So it's going to be negative cosine. And what's my amplitude? 405. That's the radius of the wheel. Boom. Okay. Negative cosine. I need to find B. All right. So B is 2 pi over the period. 2 pi over 38 simplifies to pi 19ths. There's your B times T. No phase shift needed. And then plus 415. So here's how I graded that. Your fourth check was for, do you have the right value of B? Do I see pi 19ths in the equation? Yeah. Fourth check. Boom. And then the entire rest of the equation was the fifth check. Did you put h of t equals? Do you have the other parts based upon your graph? Now, little wine, here's where if you had 405 here, you lost the second check up there, I gave you the fifth check here, or vice versa. I might have counted it there and taken it away here, but you get one of the two because you're correctly putting the wrong number in the right spot. Okay? So that you could recover on. But if your values don't line up here, like if you put a negative cosine and you shift it over to 9.5, now you don't get the fourth check. Okay, it still had to match up. All right, any questions on how to write the equation? Negative sign, that'd be t plus 9.5, negative cosine at 0, t minus 9.5, positive sign, positive cosine, negative sign, so on and so. I didn't have you write two equations. Some people did. Okay. I only had you write one. All right. Now we go to the calculator. All right. We go to the calculator and I'll work this live with you. Work it live. Work it, work it. If you want to come grab a calculator so you can work along, that's fine. Go come grab one. Unless you got it all perfectly 100% correct yesterday, you're going to want to go through the motions again. Going through the motions. We're going through the motions. All right, so I'm going to go to y equals, and I'm going to type in my equation, right? I'm in radian mode. I should be in radian mode. I'll check that first. All right, now I got -405 cosine of pi 19th. So alpha y equals, use the pi button, 19th. And then to the right, I'll put x instead of t, close parentheses, plus 415. Now, instead of just hitting graph, where do I go? I'm going to manually type in my window because I've already graphed it. This is a beautiful window. X min -9.5, X max 57. So hit window, and let's go from -9.5 to 57. Looks good to me. X scale, and you can leave it at 1. I always put it to 0. I don't even need to see the tick marks. Okay. Now, Y min, Y max. My graph goes from 0 to 820. Let's give ourselves a vertical buffer so that the writing doesn't get chopped off. So how about -50? This is just kind of arbitrary for a min. And how about 1000 for a max, right? That could vary. You could go from like -10 to 900 if you want. And then I'm gonna turn my Y scale to 0. And that's the last you need to mess with. Left, right, X min, X max, low, high, Y min, Y max, turn your scales off to 0. That's it. Now, if you typed it incorrectly, and if you're in the right mode, and if your equation is correct, when you hit graph, you should see something that resembles yours. Now, ours is much better. Some people had it bouncing off the x-axis, right? It looks like this graph kind of bounces on the x-axis, doesn't it? But if you drew your graph on your test, hitting the x-axis, you lost the graph point because it doesn't, right? That's why our graph is preferred. The numbers don't lie. We can actually see the space. All right, so that's a confirmation that we're awesome now, right? If you see a straight line going across there, one of two things might have happened. You might be in degree mode, or you might have forgotten your variable, right? Because if you didn't put your x there, you would just have y equals, it would be a number, and that graph says a horizontal line. So two things to think about, all right? But now that I see the graph, I know I'm good. And tomorrow, if you don't see your graph, start panicking, like flapping your wings really hard, and I'll come see what's going on, right? Are you okay? I don't see a graph. Like, oh, I thought you ate some hot sauce, right? But I'll try and like grunt you in the right position. All right, we're ready to answer some questions now, right? Letter C. How high are you above ground 18 minutes into the ride? At this time, are you going up or down? Show your equation and include your units in your final answer. So every single time I ask you a question, I put that. Show your equation, includes your units in your final answer. When that's part of the question, that means that the units are tied to the answer. So if you leave your units off, the answer's wrong. It's not like one check for the units for the whole thing, okay? It's a reminder. So read the directions. All right, so H of 18, right? H of 18. And now since 18's in my window, I can just hit trace 18, boom, and there it is, 814.476 feet. 814.476 feet. And you could tell from here that we're going what? We're going up, right? So going up, going up. You could have done it from the home screen as well, but in this case, we don't need to. It's right there on our screen, right? We're only going around once. So I didn't ask you, how high are you above ground like 2 hours later, right? That would have forced you to either shift your Y scale or do it from the home screen. We're just going around once. All right, so that was worth 1 point. The whole thing was worth 1 point. If you leave any of these pieces off, you don't get that point. Some people did this. Some people did H of T equals 814.476. Is that right? No, H of T is all kinds of different values. That's not H of T, that's H of 18, yeah. then you should have lost the point. Yeah. And if I didn't catch it, then I'm not going to take it away from you at this point. Okay. Yeah. If you didn't put the units and you don't have it back in front of you, so you don't know, but I'm not going to go back and regrade the ones I already grade. But if you just left off feet here and everything else was perfect, you don't get the check. Okay. So again, I told you to put units in every answer, but when you're reminded like this on every question, that's kind of an alert that, hey, the units are now part of the answer, not just one check at the end for everything. All right. So there you go. Units are part of each answer. Now, if you wanted to do this, you could have said at t equals 18 colon h of t equals that. That would suffice, but that's not the most economical, efficient way to do it, is it? Function notation is designed so that we can see the input more directly. All right. Yeah, slowing it down, right? Slowing it down. I was gonna say that's not wrong, but anyway, okay. Any questions on that one? Letter D, at what positive time, okay, not negative time, are we 300 feet above ground going down? 300 feet going down. So 300 feet. So h of t now equals 300. All right. Not h of 300. If you wrote that down, you're kind of not thinking, right? Because 300 is an output. It's a height. It's not a t value. It's not an input, right? So h of t equals 300, and then t equals underneath there. So this is how we do it, right? This is how we do it. 300. Oh, Montel. I have 1, 2, 3. I have 4 points of intersection shown on my graphing screen. Which one do I want? The third one, right? 1, 2, 3, because that's the negative time over here. That's 300 going up. There's 300 going down, right? Brady, quit peeking. Second trace, number 5, enter, enter. I always hit enter, enter. If you only have 2 equations graphed, enter, enter will automatically put you on the first, send you to the second. If you have 3 things graphed, like later on, you're going to have to toggle to make sure you're on the right one. So now I like to scroll after I hit enter, enter, because now I can move my guess along the horizontal line rather than move it along the scrolling line, which is more fun, but takes more time. Boom. And I put t equals 30.241. That's the rounded or the truncated answer. And then I put minutes at the end. Any part of that missing, it's wrong. Now, there was one wisecracker who did this. H of 30.241 equals 300. I don't like that. Is that an untrue statement? No, but I don't like that because that doesn't show the sequence of your actions. That doesn't tell me if you were given 30.241 and you plugged it in and got 300, or if you were given 300 and you found 30.241. That doesn't tell me anything about the sequence. It also doesn't give you the opportunity to put units on your final answer. So if you're the wisecracker who did that, get on board with the proper way to communicate your results. Okay, there you go. All right, you might have lost the point for that just based on not having the units. Can't remember what I did. That was yesterday, right? So long ago. A, B, C, D. Any questions on D? Brady. I don't know. I'm just kidding. Yeah. Yeah. Oh, hello, Haley. Yeah. Yeah. Letter E. Letter E. During your one rotation ride, there's a reminder again that we're going around one once. For how many total minutes are you both above 800 feet and below 20 feet? So some people answer this as 2 separate things. I kind of intended it for them to be combined. So I should have probably written the word in there for how many total combined minutes are you both, okay? But for the majority, most people did it the right way. All right, so 2 different things here. I want to know for how long I'm above 800 and below 20. So I got 2 things to do. The first thing I'm going to do is say, let's focus on the 800 first. It's just like the previous question, right? H of t equals 800 or H of t is greater than or equal to 800. Now I'm going to go to my y equals, and I'm going to put this at 800, and I'm going to do these one at a time. I'm going to hit graph. There I am on the Ferris wheel again. Now remember, I graphed this for more than one ride, yes? So if you graph it like that, you might mistakenly tell yourself that I need to find both of those pieces, right? So here's what you can do. This would be the good time. We only graphed it in that window to confirm what we graphed, but now would be a good time to go back to your window and just change your X min to 0 and your X max to 38, right? Which is how long it takes to go around. This way, now you're only focusing on your excursion through the Dubai skies, right? Okay. Now, again, it looks like you can't really see, but you could tell that it's going to cross it going up and cross it going down. I need to find those values. So second trace number 5, enter, scroll to the left. Boom. Okay. And I'm writing that one down. I'm calling that T sub 1, 17.091, and I'm going to store that as A. So I'm going to put equals A on my paper, and I call it T sub 1. Now, again, how do we store that as A? Pay attention if you don't know how. Get back to your home screen. That's second mode, just to the right of the second button. Second mode, that's your quit. Second mode. And now just hit X. If you want to hit X enter first, so you can see it, that's fine. But you don't need to hit X enter. Just hit X stow right there, and it gives you the arrow, and then alpha A. I like A because it's right under alpha. Hit enter to lock it in. Boom. Now it's A on my calculator, it's A on my paper. Fun. Let's do it again. Go to graph, hit second trace number 5, enter, but now we scroll to the right. Enter. If you get 17.091 again, you need to scroll closer to the other one. I get 20.908, and notice I'm reporting 3 decimals. I don't need units here because it's an intermediate answer. I'm going to store that as B. So we go to the home screen, second mode, and we go X, stow, alpha, B, enter. Kaboom, there it is. It's B on my calculator. It's B on my paper. If you're struggling with how to store values, come see me tomorrow early before school, before Brady gets here, because he's going to come in extra early. And I'll walk you through this, okay? But here it is. I'm walking you through it right now. Now, I know what I need to do with those. I need to find their difference, don't I? From 17 to 20 is about 3 seconds, yes? But I'm going to do B minus A, but I'm not going to do it yet. I'm not going to do it yet. This right here just says X is, this should actually be epsilon. I'm graphing it for one ride. Now I'm going to do it for 20. If you put 20 on here as Y3, that's fine. But what's going to happen is now when you do second trace number 5, you can't just hit enter, because there's 3 curves, and your calculator may automatically jump you to the wrong one. Your calculator may actually jump you, right? Give me all your money. Shut up, calculator. So I'm just going to get rid of the 800, and I'm going to graph 20 by itself, Vance. Here we go. I know it's a boring ride, right? We're only moving at less than 1 mile per hour. Some of y'all know that already. Now, it's really hard to see, isn't it? It's hard to see. But here's the deal. By symmetry, I can figure this out. If I can figure out the first point of intersection, I know I start at 10 feet above ground. So it's going to be from T equals 0 to that first point of intersection. And then by symmetry, that should be the same amount of time from that same point getting back down to 0, right? So I can either find this one from 0 to here and double it, or I can find this one separately. And then for this one, I would have to do 38 minus that one. And some people did that, okay? So let's go ahead and find the first one. Second trace, number 5, enter. And now notice I didn't go low enough, so my numbers are getting obscured, right? But have faith. I'm going to get close to it, and I'm going to hit enter. It's right there. You can see it blinking on your number. It's 1.346. So I wrote that down right here, 1.346. And I'm going to store that as alpha C. T sub 3, write it down, get to your home screen, second mode, and X stow alpha C. Boom. It's now C in my calculator. It's now C in my paper. Now, if you notice the symmetry, all you'd have to do is double that, okay? So you could do this. You could say the total time is B minus A plus twice C. That would work, okay? But some people didn't realize the symmetry, or they didn't want to take the chance. So to find the other time interval, it would have to be 38 minus that second value, okay? which gives you 1.346. So then you'd realize it's the same one. You can store it as it's already C. Okay. So there it is. There's the formula right there. So now, since I have it stored, I'm going to do, okay, I'm going to use parentheses, right? Alpha B from the home screen minus alpha A, close parenthesis, plus 2 times alpha C. Big bucks, no whammies. Yeah, baby. T, not T sub whatever, but the actual value of T that we were interested in is now 6.510 or 511, rounded or truncated, minutos, right? So a little over 6.5 minutes, we were either below 20 feet or above 800 feet. Same idea on tomorrow's redo, just different numbers, right? Just different numbers. Same idea. Same idea. Okay. All right. Everyone okay with that? You need a little more time to write it down? All right. And then we get to the applications of linear and angular velocity and arc length, right? Which was just like example 1. So anyway, y'all worked example 1 primarily when I was out last Tuesday, right? And you watched the video, but it was still the video of me going over example 1, right? And it's in the shared folder. During any given half-hour period, ooh, I'm tricking you with units because our graph is measured in what? Minutes or hours? Minutes. So, ooh, a half hour. Nice try, Mr. Corpy. I'm not going to let T equal 1/2. I'm going to let T equal what? 30, right? 30 minutes. So during any given 30-minute period, any 30-minute period, it's all symmetrical, 30 minutes, going around the ride. Through how many feet do you travel through the Dubai skies along the circumference? Show your equation. Well, we need to figure out the angle because the formula for arc length is S equals R theta. We know the radius is 405 feet. Yeah, I gave it to you. How do we figure out theta? You remember the clock problem that was on the previous 2 exams? If a clock travels 19 minutes, what fraction of a rotation does it make? 19 out of 60, 19/60th of a rotation. Well, in this case, it travels 30 minutes out of 38. There you go. So that's the key. To find theta, or to start off finding theta, we're going to look at 30 minutes rotated out of what takes a full rotation, 38. So we went 30/38ths of a rotation. Now, how do you convert from rotation to radians? Right? This is the same as rotations over 1. Rotations in the bottom, radians in the top. 1 rotation is 2 pi. Okay, so there it is. Now, what I did is I simplified this because I need to use it. I just typed in my calculator. I'll show you what I did. You don't have to simplify it here, but you can, right? I left pi out and I just went 30 divided by 38 times 2. Hit enter. And then I hit math, enter, enter, right? Math, enter, enter converts it to a fraction. So that gives me my simplified 30/19ths, and pi is still there, right? So that's a way so you don't have to store it. If you went ahead and multiplied it all together and got a decimal that was pi in there, then you would just store that or keep it on the previous line. But now I have my simplified angle in radians, and now I can bring it back over here. So 405 feet times 30 pi/19ths, radians, which are unitless. If you do it all again and leave pi out, you get 12150 pi/19ths feet, which no one did that. Most people multiplied it all out. So you get 2008.965 or 2008.966, okay? Multiply it all out. And that's feet. And again, you had to have units tied to the answer. I think 1 person had the right answer, but forgot to put feet there. And I'm like, oh, es tut mir leid, Albert. You get no points. I'm very sorry, but you get no points. It was only worth 1 check. So sometimes towards the end, when we do stuff like that, it's a lot of work to get 1 check, but if you don't know how to do it, it's only 1 check loss, okay? S equals R theta. If we had looked at a 35-minute period instead of 30 minutes, what would be the fraction of a rotation? 35/38, 35/38, right? Yeah. And then you multiply by 2 pi. Very good, okay? So that's how you take care of that. All right, and then the last part, finally, right? 38 minutes seems like a long time to get all the way around, and it is, right? How fast are you going along the curved path? In other words, what is your linear velocity? Well, we pull out the old handy dandy formula. Linear velocity v is equal to r omega. R is the radius. We know that's 405 feet. What the heck is omega? What? It's a letter. It's a Greek letter. It's not a W. That's your angular velocity. That's how fast you're spinning. That is how fast you're spinning. So do we know what that is? Right? Like in your car, the tachometer is your angular velocity of your camshaft. Revolutions per minute. Do we know the revolutions per minute of the wheel? Yeah, it makes one rotation or one revolution every 38 minutes. Wow. Imagine if the Russians were that fast. One revolution every 38 minutes, right? They'd be fighting a lot of wars, losing a lot of wars, right? They got one every 6 weeks right now and they're losing it. Anyway, that's another story, right? North of Kiev, they had a bunch of publicity. There's Russians kind of retreated and Ukrainians went in there and just sad, just ravaged corpses, civilian corpses, even just all over the street, random places. So you didn't follow the news yesterday. There, everyone's, yeah. He left the capital for the first time in 6 weeks. The Volodymyr Zelensky to look at the carnage and calling it war crimes now, which everyone kind of suspected. Anyway, we're getting off the Ferris wheel, right? And we're not even at the bottom yet, so that's dangerous. So let's get back, right? One rotation every 38 minutes. So I'm going to drop that in there. Look, 405 feet over 1 times omega, 1 rotation per 38 minutes. Now we have feet rotations per minute. I want it to be in miles per hour. This is your super duper stoichiometry problem, right? We just need to get from feet rotations per minute to mph. How do we do that? Dimensional analysis. I start with the feet in the top, feet in the bottom. I need to get to miles. How many feet in a mile? 5 tomatoes. 5 tomatoes. Good. So feet divide out and I have miles. So I have my desired units of miles. Now I'm going to get rid of minutes. Minutes in the bottom, so minutes in the top. I want hours to appear. 60 minutes in 1 hour. Minutes are gone. But I still have rotations. No bueno. So 1 rotation in the top. So I put 1 rotation in the bottom. 2 pi rad. Rotations divide out. And of course, radians are not really even units. So now I take inventory. What am I left with? Miles in the top. Hours in the bottom. Is that what I want? Yeah. Now I can't go wrong. All I got to do is type it in. All right. And in this case, pi's in the top. So I'm not going to type it all in because you can do that. The 405 divided by 38 divided by 5280 times 60 times 2 times pi. If you have multiple factors in the bottom, just keep hitting divide. I said I wouldn't do it, but I'm gonna, right? Watch this. 405 divided by 38 divided by 5280 times 60 times 2 pi. We don't have to worry about putting 2 pi in parentheses because it's in the top, not the bottom. We're not dividing by it. So it's 0.760 or 0.761 mph. Now, if you got that number, you might have done the calculation again, like, that doesn't seem right. But I try to hint to you in the way I was asking the question that you should expect a small number, okay? And it is. It travels less than a mile per hour. And that's how those wheels can stay constantly rotating. If you want to get on, they don't stop the wheel for you. You're just like, oh crap, I'm going to, let me slow it down, right? Okay, there's the cart. Okay, I'm going to go ahead and get into it. All right. Whoa, right? And now you're on it. And you can get off the same way, right? You can be like, okay, I'm getting off. Whoa, whoa, like, see ya, right? It's very slow. So you get to enjoy the scenery as well. Now, if you got to pee when you're up there, you're like, huh, I guess the blue waters of Dubai are going to be turning a little yellow, right? Blue Waters Island, right? Yeah, after I went, yeah, yellow water. They don't have toilets in the cars, I think they call them cars. Now they are outfitted pretty nicely. You can imagine Dubai, you get in one of those, there's like wet bars and all kinds of stuff in there, like plush couches with leather. There's some luxury suites. So it's not just like the Comal County Fair where it's all like rusted metal and you're just sitting in there all uncomfortable. These are plush. Yeah. I told you when I was in high school, I was going to ride the zipper and I waited in line, on whatever night. And, it's just wherever car's up is the one you get into. Well, the people that were in the car in front of me in the zipper, they had thrown up. And the carny has his little hose right there, right? The people got out, and he goes, sprays off the inside really well, gets every little chunk out of there. Not really, but he sprays it out, the seats went, and he's like, next. And I'm like, crap, I stood in line for 45 minutes, but I don't want to get into that one, but next. Okay. So I get in there, and now, the smell is still in there, and now it's extra wet, and you're flipping all around. So you're getting all of that just splattering all over you as you're flipping around. I'm like, I should have not gotten on this one. Right. And it almost makes you want to throw up in there too. It kind of makes you wonder if those people threw up because they got into a cart where someone had thrown up before them. It's like a perpetual throw up machine, right? Being splattered with wet puke as you go through the ride is going to make you puke. Yeah, it's like a yawn, right? You see someone yawn, you yawn. You see someone puke, and you're puking as well, right? If you've ever seen that scene from Stand By Me, seen Stand By Me? You need to watch it this weekend. There's a scene where there's a pie eating contest, and let's just say there's a lot of sneezes that catch on. All right, so that's it. Y'all can do that tomorrow, right? Absolutely. It'll be the same types of questions, different numbers. Different numbers.